Hello, what's up everyone? Welcome to this live stream where we are going to cover a topic which, if I guess from the very positive response I had when I announced the live, is something that you are quite interested in. And so that topic is how to cache the result of an API call and more generally, how to cache network data. And we could even say even more generally, how to cache any kind of data or computation. The reason why I'm saying this is that, as you're going to see in this tutorial, we're going to use a built-in type of foundation which is called NSCache. And actually, it's been quite some time since I wanted to make some content around NSCache. I just never came around to just writing it down. And a few weeks ago, I figured out that there was this tutorial that was published by Apple, which seemed extremely well made. And when I went over it, I saw that it covered basically everything that I would have wanted to say in a video about NSCache. So I was like, all right, since they've done most of the job, let's just use what they've done and build upon it if necessary. So as I was saying, we're going to follow a tutorial made from Apple. So as usual, you have the link to the webpage, which you're seeing just right behind me in the description. And last thing before we start, this is recorded live. So if you're watching live, first, welcome. Thank you for being here during the live recording. And also, if you have any questions, any remark, please feel free to say it in the chat. As always, I do my best to answer them. And don't forget that whatever question or remark that come to your mind, people watching the replay probably will have the same. And so by voicing them, you're giving them a voice, which is pretty cool. And I think that's all I want to say for the intro. So let's get started. So the topic of the day is caching network data. So this tutorial is part of the Apple dev tutorial. So I must say that in the past few months, Apple has made a really big effort into publishing high quality tutorials. They published the series of tutorials on how to get started with with developing for iOS, and I covered this tutorial in the past few weeks. They also made a great tutorial on how to get started with Swift Data, one on how to get started with visionOS, which I haven't yet covered. And this one, so it's actually, so this chapter, caching network data, as you can see, it's part of a much larger tutorial, so I won't cover it all, but I'm going to cover this part in network data, and maybe if you like this format, I will look and see if there are other chapters which make sense to be covered as a standalone. So what are we going to do in this tutorial? So this tutorial is going to deal with an app which is a client that fetches data about earthquakes. So it fetches a list of earthquakes from the network. And what we're going to do is that we're going to start from a project which has already been made, and we'll extend the client to fetch the location details for each earthquake. Each earthquake requires one additional fetch to retrieve the local information from the network, and we're going to make multiple network connections concurrently while maintaining a cache of replies. And you will see that we'll use this cache in a way that not only will we not be making another call for the same data after a first call has completed, but we'll also use it in a way where if we attempt to make a second call while the first one hasn't yet completed, we'll also not start a new call and wait for the result of the one that's already on flight. That's why I was saying that this tutorial is quite well made. So download the starter project and follow along with this tutorial, or open the finished project and explore the code on your own. So this link right here, it downloads a zip and you have two folders inside of it, the starting point and the completed project. So I've already downloaded and opened in Xcode the starting point, and I would recommend that you do the same. This way, if you follow the tutorial with me, you can code along, and as you will see, coding along is what really helps you understand what's being taught by this tutorial. So before I go further, let me make myself a bit smaller because I don't want to cover the code. The code is way more important. So section 1 is about fetching Quake location. So each Quake object in the USGS, so if you're wondering, USGS, I looked it up. If I can, I'm trying to do the first click to look it up, but it doesn't work. Can I just do like search? Okay. So it's, of course, it's in French, but it must be like US geological something. But it's like it's an official like geological study institute in the US. So they publish a feed that has details that has a details property with a URL value. The URL provides additional information for the quake, including its location. And so this app deals with earthquakes, but the pattern we're about to see is something that's quite similar when you're implementing an API inside an iOS app, is that you will have a first call that will give you a list of objects, which you will display in a list to the user, and then the user will select one object and you will fetch details about this particular object. Or maybe also what's possible is that you fetch the list and then you display a card which contains some details about the object, and so you need to fetch the details for all of the objects which are displayed on the screen. But you don't want to fetch for all of the objects because maybe there are 100 objects in your list, but you only display 6 or 8 on the screen at a time. So this is this very common pattern that this app aims to simulate. So in the previous chapter, this tutorial showed how to decode the data from a JSON. I won't cover this in this live stream, but if you want to learn more about how to decode JSONs in iOS, know that there is a chapter that covers it. And in this section, we're going to update the client, so the app, to fetch and decode a Quake location. So first, the app displays a list of Quake objects, and then we want to fetch the Quake location. So the app will cache every location it fetches in an instance of NSCache, and I guess the idea is probably also that maybe several Quake can also refer to the same location, and so this way you don't want to fetch the data more than once. And that's also a very interesting pattern. Might be slightly less common because sometimes you will fetch the details of an object, but this is a very interesting pattern because it makes caching even more important. Because if you imagine that you have like 100 Quake objects, but they only use 20 locations, that each of them that like more than one Quake object uses the same location, then you don't want to fetch the same location more than once because it doesn't make sense. You're just wasting data, you're wasting also energy on the user's device. And so each entry in the cache is going to hold one of two values, either a Quake location structure, so data fetched from the network, or a task that is loading a Quake location structure. And that's why I was saying that this tutorial is really well made, is because it covers the case where what's happening if the data for this specific location is already being loaded. And in that case, you want to wait for it to be loaded and not send a second network call in parallel. So that's going to be very interesting to see how they model, how they design this in code. And later in the tutorial, we're going to use the cached task to avoid making duplicate network requests. What's really nice also is that, as you can see, it's talking about task, and so this tutorial is made using Swift concurrency, so async await, the more modern API, and it's really great to see it because if you see an example, if you look for example of tutorials about NSCache, since NSCache has been along for such a long amount of time, sometimes it can be like quite old code that maybe uses compression handlers or uses Combine or uses Rx Swift. So having a tutorial that uses async await and Swift concurrency is really a nice addition. So how do you represent the fact that a cache entry could be either in progress with a task or either something that's ready with a URL? So when I said the word either, if you've done a bit of advanced data modeling in Swift, this might have ring a bell. And that's because we're going to use a Swift enumeration, which is a natural way to model this cache entry, because it allows us to model the cache in a way where we have two cases which are mutually exclusive. So you'll create, so NS cache is designed to hold reference types, but a Swift enumeration is a value type. So we need to create a class to hold the enumeration and insert an instance of this class into the cache. The reason is that NS cache is quite an old type that dates back from the days of Objective-C, and so enumerations, Swift enums were not part of the game back then. So in this section, we're going to create the necessary types to store locations and tasks in an instance of NS cache. We'll use Swift generics and subscripts to hide this complexity from the code that actually accesses the cache. So step one, we're going to create a new Swift file named cache entry.swift that cache entry object.swift that contains a cache entry enumeration. So let's go into Xcode. So as I've said, I've downloaded and opened the starting point. So where are we going to put this file? I'm going to put it in a model, I would say. So I'm creating a new Swift file. I call it, as they said, cache entry object. And I'm just going to copy and paste the code to go faster. But if you're following along, I really recommend that you write it by yourself, because writing it really helps, like remembering it, and it makes it so that when you just watch a video, it's very easy to have some like surface knowledge that you're going to forget very fast. And I would say that writing the code yourself helps have things like stay a bit, be a bit more rooted in your brain. So don't follow my example of just copy and pasting. So I'm creating this enum, so-called cache entry. And what can be a cache entry? It can be one of two things. It can either be an in progress, and in that case, you have a task associated with it in the associated value, and this task is going to yield a Quake location, or an error if something wrong happened while the network call was happening. Or the cache entry can be data which is ready and which contains a Quake location, so the result returned by the task. By the way, this makes me realize that there is a small mistake, I think, in the tutorial, because it says that so this is correct, but at some point it was saying like a URL, or maybe I read it wrong. Oh yes, here you see, here it says ready and URL, and it's a mistake. It's ready and Quake location. So maybe there is a URL inside of it. I don't know, but here that seems a bit weird. We'll see like if there is an explanation for it. Maybe there is one. So what do they say here? They say that we'll use the in-progress enumeration to avoid making a second network request for a location that has been requested but not loaded. And this is like one of the nice features of a well-implemented cache that you might not think about it immediately. Like if someone asks you what a cache can be useful, you could say that it's useful so that you don't make again a call that was successfully made in the past, but it's also that you avoid making several calls in parallel that are actually loading the same resource, but each of them is not aware that it's already happening and triggered by another place in the code. So that's very good that they also cover this use case. Okay. So then we're going to talk about NS cache. So NS cache can hold only reference types. So reference types, it's basically classes, and to be fully accurate, reference types, it's classes, actors, and closures, if I'm correct. So to store enumeration in the cache, you need to create a class that holds the enumeration value and store it in the cache. This process, it can sometimes be referred to as boxing and unboxing in terms of design patterns. If you ever had to write like Objective-C and you had to use NS number whenever you would want to store an int or a float into a collection, this was a typical instance of it. So we are creating a new class called cache entry object. So let me first add it into the code, and then we'll see what they have to say about it. So they say you can safely pass any instance of this object across threads because the final declaration and the let property make every instance immutable. So basically, it offers the same immutability guarantees than a struct would. So it's a very specific kind of class because it's marked as final. It cannot be extended. So another class cannot inherit from it. And the only property is constant. So the goal is really to expose this, but expose it as a reference type. That's the only thing it does, hence this name of boxing this value into this box. So step 3, we're going to create a new file named nscache plus subscript that contains an extension for nscache. So I'm also going to put it into models, even though maybe it should go like more into a utils, but I'm going to leave it into models to simplify. So nscache plus subscript, and we're going to write an extension on nscache. What do we put inside this extension? So first we need to constrain the extension to nscache types with an NSString key and a cache entry object. Okay, so let's copy and paste it. So what do we have? So we say it's an extension of nscache, but what we'll declare in this extension will only be accessible when the key type of the nscache is an NSString and the object type is a cache entry object. Let's actually do a command click just to see. So this is Objective-C, so don't be scared if you've never seen Objective-C. We're just going to follow on this line. I want to show you that nscache, so it's a class defined in Foundation. And you can see that it has two generic arguments. The first one is a key type and an object type. And honestly, on a conceptual level, you can really see nscache as a dictionary because it stores keys and values, except that here the values must be objects. And basically the main difference, and I think we'll cover it later, is that nscache has a strategy so that if you put like too many values inside of it, it's going to start removing all values. There is a cache eviction policy. But other than that, the logic of an nscache is very similar to a dictionary. You add objects, and these objects are indexed by keys, and so you subscript the cache in order to set a value for a given key or to retrieve a value for a given key if such a value had already been set previously and had not been removed from the cache in between. That's the subtlety of using a cache rather than a dictionary. So here they say that the code that you add to the extension applies only to instances of nscache with a matching key and object type. All right, next step, add a subscript that takes a URL and returns an optional cache entry. If you're not familiar, by the way, with what a subscript is, it's what you do when with a dictionary or an array, you do something like this. So something like that. So something you see like this. So what you do when you do this syntax is that actually under the hood, you call a special method called a subscript, which takes this as its argument. And so here we're going to implement a custom subscript. So we do it with the keyword subscript, and you can see that this subscript will take as its argument a URL, and it will return an optional cache entry. So if there is something in the cache, it will return it. Otherwise, it will return nil. And so they say defining subscripts lets you read and write to the cache with a notation similar to dictionary. So what I was explaining just before. So they say here, note, Xcode indicates a compiler error until you implement the subscript in the next step. That makes sense because there is a return value, and for now, we are not returning anything. And it says here, missing return subscript expected to return cache entry optional. All right. So we're going to add a getter first. So it's what happens when we are reading data using the subscript. And this getter is going to retrieve a cache entry object from the cache and return the cache entry inside of it. So let's copy and paste the code and have a look at it. So in the getter, we take the key, we take its absolute URL, and we cast it statically as an NSString. Then we do object for key, and here it's really self.object for key, so we are calling this method on the cache. So similar to doing something like this, very similar to this syntax. And if there is such a value, then we take the entry. So remember, the entry is the property stored inside the cache entry object, which is the box which allows us to store a cache entry, which is an enum, into an NS cache, which expects a reference type like a class. All right. And what do they say here? They say that because of the generic constraint on the NS cache extension, the method object for key takes an NS string and returns an optional cache entry object. So this here is typed. So this here is typed because you can see that the argument is of key type and the return is of object type optional. And we've already constrained both these generic types in the declaration of the extension. That's why here this value is of type cache entry object optional, and this argument here is of type NSString. Next step, we add a setter. So for when we use the subscript to set a new value with the equal operator, the assignment operator. So add a setter that stores a cache entry object into the cache, and as you can expect, it is going to be symmetrical to the getter. So what we do is that once again we take the key from the URL, and then if we've set an entry, so if we haven't set equal nil, then what we do is that we box the entry into an object and we set that object for the key. Interestingly, there is no else clause. So if we do equal nil, it's not going to remove the value from the cache. Maybe we'll do it just after, but otherwise that might be something that would be missing in an actual implementation. Okay, no, they cover it just after. So I was just getting ahead of things. I see a few people that have joined in the chat. So hi Omer, hi Junaid, hi Juan, nice to see you. And don't hesitate if you have any question or any remark. So inside the setter, they tell us the compiler synthesizes a new value variable that, as you can see, has not been declared anywhere, that you can use to access the incoming value. So here they call it a variable. I would call it an argument because it's really an argument. When you do, for instance, if you do something like cache of a key equal a value, then this value right here will be bound to this argument new value right here. And that's a convention that the argument holding this value is called new value. So now we handle the else clause. So what happens if we attempt to set nil? So let's copy and paste the code and have a look at it. And so it calls remove object for key. So that's what I was expecting and what I was mentioning just before. And so this behavior of removing an object when nil is assigned mirrors the behavior of dictionary. As you can imagine, if we didn't implement this, it would be quite an issue because first, we wouldn't do what the developer expects us to do. So it's something to be really careful about when you implement the setter of a subscript, is that you want to make sure that you handle all of the possible values and that you don't leave any possible value that could be assigned unhandled, because if you do that, whoever calls your code, calls your subscript, will not be aware of it, and that's a really good recipe to get some really nasty bugs. All right, next we move to something that is part of the existing code. So by the way, let me launch the app so that we can see what it looks like before I start changing the existing code. So you can see it shows data about some earthquakes, and we can reload here. We can pull to refresh, and if we click on an earthquake, for now it doesn't do anything. Okay, so they said to go into Quake client. So we are into this file, and what do we do in this file, which is, I would say from the looks of it, the code that implements the client that fetches data from the network. So they say we need to add a cache. So we add a Quake cache property. So let's put it right here. So we use an NS cache whose key is an string and object type is a cache entry object, and we initialize it like that. So they say because the NS cache generic parameters are the same as the extension constraints, you can use the subscript we've just defined to access the contents of the cache as you would expect. Okay, we've done the first section. Let's move to the next one. So cache quake details. NS cache is thread safe, which means that you don't corrupt the data if you access it from multiple threads. That's a really great property of it. But you want to make sure that each location is fetched no more than one time when accessed from multiple threads. The thread safety of NS cache isn't sufficient to guarantee that, because you could still end up making several calls because the first call hasn't finished returning its data, so the data hasn't been stored into the cache, and the second call for the same data has already started. So a common challenge with multi-threaded code is the unpredictable order of execution. For example, consider the steps in the image on the right which represent the out-of-order operations that are characteristic of multi-threaded applications. The two colors represent two different threads. When the first thread in yellow waits for network access, a new method execution in red begins before the previous network access finishes. This second thread shouldn't initiate another network fetch. Instead, it should wait on the fetch already in progress. So you can see the first thread checks for the URL, no data found for the URL, makes a request, stores the task, waits for response, and what we want is for the second thread, if it checks for the same URL, to find the cached task and wait for the response instead of also starting to make the same request for the same data. In this section, we're going to use an actor type to protect the cache. This actor ensures that access is serialized, but it leaves one potential issue. When you call await, as you do when fetching network data, execution pauses and the actor can start executing new function calls before the network call finishes. You'll address this issue by making sure the cache has a value before waiting on the network request. The second thread will find a cached value when it begins executing, avoiding an additional request. That's why we're also storing the task that will ultimately yield either the data or an error. So they say, add a quake location from function that fetches and decodes the location. And so we're supposed to add it at the end of the file right here. So let's add the code and let's go over it. So it takes a URL, it returns a quake location, and it's going to do await downloader. What is this HTTP data downloader? Okay, it's just a wrapper around It's a wrapper around it's a wrapper around the URL session, essentially. Okay, so it downloads the data, then attempts to decode it, and just return it. So if you followed any of my live streams where we ended up making API calls, it's exactly the same pattern that I was using, except that here, this part of the code is encapsulated into a specific function, but this shouldn't be new to you if you've written any kind of API call in Swift, because it's almost always the same pattern. And if you've never written an API call, by the way, I also have a video called How to Write your First API Call. So go check it out if you've never implemented an actual network call in iOS. Okay, what do they say here? Important. The current implementation of Quake client may make multiple requests for the same URL. In the steps below, you'll update this initial implementation to correct this issue. Okay, yes, because that's what we want to avoid. Okay, so first they say make the Quake client an actor type. So we'll change the class keyword to actor. What's an actor? Basically, you can see it as a class, except that it cannot be used at the same time by two different threads. So when you interact with an actor, you use the keyword await, and if the actor is already being used by another thread, then the second method call gets queued until the first one has finished. So that's the gist of it. Here, what do they say? They say that although Quake cache is defined as a constant, the internal state of the cache object that it refers to can change because it's a reference type. Making Quake client and actor protects the cache from simultaneous access from multiple threads because the property is private. And so since we've turned our Quake client into an actor, now it has become impossible for two threads to access this property at the same time. Okay, next, we're going to update our code in Quake location a bit, and we're going to create an explicit task to fetch the location. And they say that creating a task gives you a way to store the task and check its progress later. You save the task in the cache so that future fetches wait on the in-progress task rather than issuing a new network request, which is indeed the behavior that we want. So you can see the code is very similar. We've basically wrapped everything inside a task, and we are storing here what's called a task handle. But you can see that now the code no longer returns because we're supposed to return a Quake location and we're not doing it. The task returns a Quake location, but we still need to return the result of the task. So let's try and how we do this. And they say that there is a compile time error, so this is normal. So then store the task in the cache because we haven't done it and await the result. So let's copy and paste the two lines and have a look at them. So we store here the task in the cache, and here you can see that we are using the subscript that we have implemented right here. So this method right here is what's being called here, and more specifically, since it's an assignment, we are calling the setter here. And then we store the location. So by doing await task.value, so this way we say we want to wait until the completion of the task and gets its value once the task has completed. We still have the error because we still need to do something with the location, maybe return it, for instance, but maybe we want to update the cache before we do that. So here what do they say? They say that recall at the await keyword marks a suspension point. Another thread might call Quake location from while this thread is suspended. So yes, so while we have this await here, another method call on the same actor can indeed start executing. Good thing that they mention it. And then, so they say now, store, so once the task has finished executing, so once the network call has successfully returned, either with some data or with an error, we want to store the final Quake location in the cache and return that location. So it's these two lines right here. So you can see that we update the cache again. This time, for the same key, we set the ready case of the enum with the location, so the data returned by the task. And finally, we return the location itself. And so, thanks to this, if a second execution of Quake location starts while waiting for the task, it will make a second network request, so we'll fix this issue below. So what do they say here? They say that, yes, because as you can see here, before creating the task, we are not checking whether or not there is already a task in progress. So I guess before the line 29, we're going to add some code to say if there is something in the cache, don't start a task, do something else. But first, they say that the project should now build successfully. So let's make sure it does. Yes, it does build successfully. So next step is to add a do catch block to catch an error, remove the task from the cache, and rethrow the error if an error happens. So we do it here. So we do try. So if there is an error, we go here, and in this case, we remove the entry from the cache and we throw the error because this method is already throwing, so we're allowed to do this. And otherwise, then we have our happy path here. So we set the result in the cache and we return it. All right. Step 7, at the beginning of the Quake location from URL method, check for a cache value. So that's what I was mentioning. I had the right intuition. So we check whether or not there is already something in the cache, and it could be either a result or a task that is already in flight. And since it could be both, we're going to switch over the value, because what do you do when you have a value which is an enum? You switch over it. So we're going to switch over it, and in case it's ready, we're going to just return the data as was previously saved, and otherwise we're going to wait for the task completion and return its value. And what's nice is that you can see that potentially for the same task, we might have several places where we wait for the task completion, and there is no problem with it. You can have several pieces of code that all wait for the completion of a same task, and all of these places will become unsuspended, will resume as soon as the task has finished, either because it has yielded or yielded. I'm not sure if you say yield or yielded, because it yielded a value, or because it threw an error. And so they say here, waiting on an in-progress task here avoids making a second network request. So that's really the part that makes everything works as we want it to. All right, now section 3, fetch multiple locations. So it's time that we use this cache that we have just implemented. So our client caches location data, and it properly deals with multiple concurrent requests. In this section, we'll update the client to fetch location information for a number of earthquakes simultaneously. We'll use a task group to start a number of network requests. We'll request the location for all the earthquakes in the past hour. Because the number of earthquakes in the past hour varies with each run of the app, we'll use the task group to dynamically add operation, because we can't predict at compile time how many concurrent calls we'll need to make. Then we'll wait until all operations are finished and update the appropriate quake structures. When the client returns the array of quakes, the most recent structures will have their location property populated. Okay. So in the model quake.swift, we're going to add a property, an optional property, quake location. So let me go into Xcode, open this file quake.swift, and add this property right here. So it's optional because we could either not have it at all or not have it when the object is created and it's only fetched later. All right. Next, in quake client.swift, we create a local variable named updated quakes. So we do it in that in the compute property to get the array of quake. So back into quake client. So we have here this compute property. By the way, to be honest, this pattern of having a compute property which under the hood makes a network call, I would say it's quite a bad pattern. I would recommend using a method instead of a property, because when you call it, when you do like quake client.quakes, it's not clear that it starts a network call under the hood with all of the cost it carries with it. So I would really recommend using a method rather than a compute property here, to be honest. Okay, so I need to update this. So what do we do? Before we just returned the quakes, and now we create this local property, which I guess we're going to use a little bit after inside the body of this compute property. So yes, they say fetch the index of the first element with a timestamp greater than an hour ago. So I guess that's because if the data is from less than an hour ago, you don't have the data that we're going to fetch available. Let me hide on the left so that we have a bit more room for you to see. So if we have something older than 1 hour, and so it takes the collection and looks for the first index where the time interval since now is greater than 3600, which is the number of seconds inside an hour. So it's 60 times 60. And what do we do inside this if statement? And they say that the array of earthquakes is sorted from newest to oldest. So when it will stop, it's when it will have found the first earthquake with its time being greater than 1 hour from now. So step 4, create a range of indices that indicates all of the earthquakes measurements in the past hour. Okay, so actually it's the other way around. Is we want to find the earthquakes from the last hour. So it's all the way from the beginning of the collection. So it goes from start index, which if the collection starts at 0 is going to be 0. It might not always be 0 because we might be dealing, for instance, with an array slice, which might be a slice of a much bigger array. But the start index all the way to the index of the first item whose time since now is greater than 1 hour, and you can see that we do ... less than, so it means that this is not included in the range. If we had done this, it would have been included, but this one makes it not included in the range. And then we create a task group. So let's copy and paste the code first. So like that. So it's a throwing task group, and it's a task group of tuples of int and quake location. So let's see what I have to say about it. So the tasks in the group return a value of type tuple of int and quake location, which represents the array index and the location. Then they say iterate through the indices and add a task to fetch location for each earthquake. So this is the part that looks like your usual serial code. So we iterate over the indices in the index range, and for each index, we add a task to the task group, which is created here and made available inside the closure. And so we add a task. And what this task does is that it calls the method quake location, which we've implemented just before and just below, and it gets the result and it returns a tuple which contains both the index and the location. And the reason why we need to carry over the index is that because when you look for the results of a task group, it doesn't return the result in the order in which the tasks were added, but in the order in which the tasks have finished. And so if you want to have a way to refer back to the index of the item, you need to pass it explicitly. You can't rely on the order in which you will be reading results from the task group. But I'm sure they will mention it just a bit after. So we've added tasks to the task group. Now let's read the result. So for this, we're going to use a while loop. So what it does is that it's going to iterate over the task group, and until there is a next result to be read, we're going to stay inside the loop. So the next result method returns a result of either the tuple of int quake location or an error. And so I guess we'll also write code to deal with the error. Yes, we're doing it right now. So we're switching over the result. If it's a failure, we just throw the error. And if it's a success, what we do is that in the array updated quakes, we set the location of the property location to what we have just fetched. I'm seeing a question, so let me answer it. So would it be a good idea to use a cache or database as a single source of truth in your app and just make network calls to update the cache database? So it really depends on what you want to do. The difficulty with caching is that caching comes with the complexity of when do you need to clear the cache. I'm going to give you an example for it. Using the typical example is when you deal with a banking app. Let's imagine you have a banking app and you fetch the data about bank accounts. And then somewhere in the app, the user makes a transfer from one bank account to another. This means that all of the data that you had cached about both the source and destination accounts used for this transfer needs now to be invalidated because it reflects a past state that no longer reflects the new reality. And so when you cache data, the complexity is that you also need to handle when you need to clear the cache. And it can be quite complex to handle. So that's why I would say you want to be careful with caching data, because it can really easily turn into what looked like an easy feature that becomes actually nightmarishly complex to handle. But there are apps where having some cache can be very useful to make the data still accessible while you are offline. Typical example that I had to from an app which I had to work on in the past was an app that you would use to save your insurance information for your car. And there is a good chance that when you need to use this data, maybe you're in the middle of nowhere with bad internet. And so having the data accessible offline was very useful. So my answer would be, yes, caching is good, but caching comes with complexities of its own. So be aware of what you're getting into and make sure that you don't introduce caching just for the sake of it. There should be a clear benefit to the user. Otherwise, it just makes no sense, and sometimes it can introduce really nasty bugs that would confuse the user and which will be much more annoying than just having to remake a network call that you could have avoided making again. In this example, what we are fetching, I guess, is immutable data. Once an earthquake has happened, it has happened, and it's not going to change. So I guess it's a special case of caching where you get a lot of benefits and you don't have to deal with a lot of the drawbacks because the data you are fetching is immutable. But that's a very good question. Thank you for asking it. Okay, so what do we do next? What do we say here? They say that the success case holds an associated value whose type matches the type passed to with throwing task group. So here we said what we expect to find in as the result of the task, and so that's what we get here in the result. Okay, so our client now fetches all the relevant data for an earthquake, combining data from multiple URLs using an actor and a task group network access is both concurrent and safe. In the next tutorial, you'll create a detailed view to display all of the quake information you retrieve. So we've actually finished the tutorial, but we are not yet done for this live stream because there is a quiz at the end. But of course, also let's try and make sure that we actually have the data, because I want to make sure like this location property, is it displayed anywhere? So let's see where this quake property is used. Actually, no, this search is not the right way to do it. Maybe more here in quakes, and we search for quake row. What do we do? So here we do, okay, so we have the place, the time. You know what? I'm just going to add a new text like that, and I will do quake.location. And rather I will do if let location equal quake location. And then I will display a text with the location. And let's run the app again. Why is it not working? Oh yes, because I need to, okay. So I have the latitude and the longitude. So I need to turn this into a string. Let me see. So I'm looking to see how I can format latitude and longitude. I'm looking into units to see which I could use. I'm looking for one if there is one just for, yeah, I'm just going to use number. So location, latitude, and then text, location, longitude, and number. So it's not the best way to show data, but I just want to see on the screen that what we've done makes sense. And I forgot to say, okay, so here you need to say format. All right. Is it going to work this time? All right. Why don't we have the data displayed here? Let's see. Let's see what happens when this view is shown on the screen. So we have this quakes view. Oh, maybe I need to manually refresh it. I didn't try that. Let me try that. No. And we have earthquakes which are less than 1 hour ago. Okay. So what's happening? We are showing so provider.quakes. What's this provider? So it has this data. It has the quake client. Okay. Fetch quakes. So it gets the data here. Here. Okay. You know what? What I'm going to do is I'm going to go here in the property here, and I want to see whether or not we enter this code right here. Yeah, we haven't triggered the breakpoint. Oh, but I guess maybe because there were no new earthquakes, and the one that I had were already like maybe saved on the device. No, so this is still not being called. So we are missing the code that displays the data, which is kind of annoying. And I would want to show it to you. I'm going to see, like, is this being called at some point or not? Like if I refresh. Okay, so this is being called, and maybe actually I'm going to move all the way to here, and I'm going to try and run here. So I want to run this to see like if whether there is something here. I'm going to do PO this. Okay, so it says nil. Oh, I think I have an idea of what happens. I think I found a bug in the code. Is that since it's an interesting bug, but it seems that I want to see like no, there are earthquakes which are older, because I was like, what if there is no earthquake that is older than 1 hour ago? Then it would return nil here, and so the range would be empty, I guess. But okay, so oh no, I think, or maybe what could happen is that maybe the time is not formatted correctly, and the time is in like a US time zone, and my simulator is on a European time zone. And that's weird because here it's being displayed correctly. So, and if I go into Quake Raw, you can see that it's like QuakeTime formatted relative to now. So that's weird. Why don't we have this? Because it says, I'm gonna try and see if we ever enter here in the iflet. So it seems we never enter the iflet. Yeah, data is fetched right here. That's so weird. And let me see what we have here inside the data. No, not the data, the updated quakes. So we have this. Okay, so the app crashed. That's the joy of doing things live. You never know what's going to happen. Let's relaunch it. Okay, so this is okay. That's a valid time, all right. But what's weird is that if I look, yeah, like this is more than this is definitely more than 1 hour ago. That's why I don't get why it doesn't return anything. It's so weird because it's time interval since now. You know what? What I'll do is that I'm gonna add a colon breakpoint right here. Of course, I've forgotten how to do it. How do you? I think it's like right click should do it, or maybe I need to select the line like this. How do I put a colon breakpoint? Why can't I find how to do it? Maybe in the debug menu I can find it. So yeah, create colon breakpoint, and I don't have the option, which is kind of annoying. Okay, I don't know why. You know what? What I'm gonna do is I'm gonna try and maybe put it like this so that I can put a breakpoint on this line, because I want to see what this returns. Maybe there is an issue here. So here we have an earthquake. Okay, so the time is this one. And if I do PO $0 dot time interval since now. Okay, so I get a negative value, but I think it's a time zone thing. I think it's a time zone thing that's happening because my simulator is not set on the same oh, yeah, that's what must be happening is that my simulator is not set on the right time zone. And so because of that, what's probably happening is that the time interval, it should be a positive number, but it's a negative number because California is in the past compared to Europe. I mean, not in the past, but it's earlier in the day in California than it is in Europe. And I guess when you have the code, let me remove the breakpoint, but the code that displays here handles correctly the time zone issue, but this other code here doesn't have the same underlying logic. Like this is localized and this is not localized. I guess that's why. It's interesting, an interesting edge case. Fortunately, I should be able to solve it by going into the settings of this simulator and going into general, not language and origin, but something about where is the setting about time? Why can't I find the setting about, or maybe it takes the time of my current device and I cannot easily. I think that's why. Let me just check. I'm just gonna check if in the compilation scheme I can force something here. I can force the region and the language, but I'm not sure I can do it for the time. But I'm going to try and force the region to be like America and USA. Even though there are several time zones in the USA, so I'm not super optimistic that it's going to work, but let's just give it a try, and otherwise I will simply remove the if statement. This way we'll be able to see the data being fetched. Yeah, no, it didn't do the trick, so I'm going to remove what I made in the scheme. So I go back to system region, and what I'm gonna do is that I'm gonna actually remove the iflet here. So is it possible to change location? Yeah, you can change location, but it's not really the location. The problem is the time zone, actually, because you could have a location which is like you're in the US, but still have your phone configured to be in the European time zone, for instance. So once again, that goes to show that whatever kind of code that deals with time zone tends to be quite complex. I'm just trying to make sure that I don't break. Yes, okay, I was doing it good. So like that, not like that, like that. And so the index range, I can get away with it. And instead I do updated quakes dot indices. So it's just like if I were iterating over the updated quakes, just this way, I get to keep the same code than before. So now it takes more time to load, but we can see that we have the data being displayed correctly. All right, so what we've written has worked. At least it has worked in the sense that the data is being displayed. If we wanted to make sure that it's indeed doing its job as a cache, we would need to put breakpoints, or we could just reload, and you can see that when we reload, it goes much faster than last time, and I guess that's because it didn't need to fetch the data again. Let's see. I'm going to here have a look to see whether when I click on reload, whether or not it's calling the method again. Yes, it's calling it again, but since it's reading from the cache, it's just data being read locally, and so it goes much faster than making network call the first time, where you saw that it took a bit of time to load everything. All right, so we've seen that it's working as expected. Now let's finish this with the quiz. So 3 questions we need to answer. First one is, let's imagine that you want to create a property of type NSCache with keys of type string and values of type NSData. How do you declare the cache? So first one, let cache NSCache of string NSData and then creating the cache. This seems pretty correct, to be honest. Other one, let cache with the where. So this one is not correct. You use where when you declare a type or when you declare an extension, but you don't use where when you create a variable, at least not in Swift. This one also is not how you do it. This syntax, you do it at the declaration once again, but you don't need to give the name of the type when creating an instance. You just like the order of the type lets you know which is which between NSString and NSData. And this one is also incorrect because you don't need to use this. This one is the same than above, except that instead of an equal, it's a colon syntax, but same thing. You don't need to say, and you can't even give the name of the argument if you want it or not. So I would say it's this one, and I was correct. Is this one, and these 2 generic parameters, they supply the key and value types. Next question. So when the method AppleData is first called in the following code snippet, it fetches data from the internet and stores the result. What could cause this method to make multiple network requests? So we have an actor, AppleData, it starts a call, okay, and return it. So I'm sure you can imagine what could happen is that here the keyword await creates a suspension point during which another place of the code, another thread could call the same method on the same actor and so trigger another call while the first one is already in flight. So let's see what they have as options for the answers. If the app makes a second call to AppleData after the first call has completed, it results in a second network request. Here it's not the case because at the end we do store the result in this property that we check before making another call. So a fully loaded call, after a fully loaded and successful call, we will not be making a subsequent call if the method is called again. Option 2 is if the app makes a second call to AppleData while the first call is waiting on a network request, it results in a second network request. I would tend to agree with this one. And third one, if the app makes a second call to AppleData after the server data is changed, it results in a second network request, so no. And that's one of the problems of caching is that you might have been caching a data which has changed on the server and you have no way of knowing about it. But the correct one, I would say, is this one. And indeed, the await keyword, so right here, marks a suspension point, and a new method call may arrive during this suspension. Last question, what is the type of the result constant in the following code snippet? So we create a throwing task group that will have task that returns instances of the type myClass. We add values to the task. And then here we handle the result. And what's the type of result? And so it's going to be a result of either myClass or an error, because that's how result does. It allows you to store into an enum either the success case or the error case. So I would say it's this one. And indeed, it's this one. Be careful, there are other methods to read the content of the tasks returned by a task group, and they don't necessarily return a result. Some of them, they might be throwing methods, and so you need to do a do catch, but what you get is the actual result, and if there is an error, it's thrown, and so it goes into the catch clause. So be careful about it. This is only valid when you call next result in order to read and iterate over the results of the task group. All right, I think we've covered everything for this tutorial, so I'm really happy with what we've covered in this live stream, because we've seen how NSCache work. We've seen a great example of it where not only do you cache the result of successful requests, but you also add the necessary code in order not to start a second call for the same URL while a first call is already in flight but hasn't returned yet. So once again, great job on the team at Apple that made this tutorial. It's really nice. As always, so big thank you to people who have been watching live and who made good remarks and asked good questions in the chat. I hope that you've enjoyed this live stream. There was quite a positive vibe when I announced it, so I hope that it's been up to the level of what was expected. And I guess I just have to say, yeah, thank you for watching, and see you next time for another live stream or another video. Bye bye.